Oh, give me 2 seconds. I don't have my calculator.
We're good.
Ugh.
Gotta grab a pencil.
Okay, sorry, I'm back.
You're good. I just need to find a pencil that works.
Yeah.
Okay, I got it.
Awesome.
All right.
So it's just like 3 cos of 3 root 3, comma 3 sine of 3 root 3 for polar coordinates and stuff? Or am I really confused?
Sorry, what? Say that one more time.
Sorry, I just woke up, so I'm a little...
You're good. Okay, so
you.
yeah, we're just converting these. This should be pretty easy.
Yeah.
Let's make sure we have the same. Yeah. Okay. So, you want to find R first?
They gave us polar coordinates. Oh, just kidding. That's why I'm so confused.
No. Oh, yeah, they give us regular. We turn it into polar.
Oh, my goodness. I was like, what?
You're good. You're good.
It's like, these aren't nice numbers. Oh, my goodness. That makes so much more sense. I'm clearly missing something here.
Right. Right. Let me know when you get some.
Okay, I have something.
Okay.
Radius,
Did you get 6?
6.
Oh, you did write it. I wasn't looking. And pi over 3? Yep. Cool, that's what I got too.
Yay, I did it right, probably. I love it when things aren't terrible.
I know, this was like such relief after last week. Last week was just kind of over my head, but
yeah.
Get polar coordinates. At least I get changing them.
Yep. Polar coordinates is a nice break before the test.
Yep. Did you get 4 and then pi over 6 for this one?
Probably. Let me find the angle.
Okay.
X is... Yes. 4 pi 6.
Are you tired, honey? What did you get for the last one?
3 root 2 pi halves. I hope.
Yeah, I think you're right. I did something wrong.
Which one was different?
Just the last one.
I know the angle has to be between 0 and pi halves, or 0 and 2 pi.
Yeah, I have pi over 4. I don't have. I got 6. Because it'd be 9 times 2, which is 18 plus 18, right? Equals 36.
Check. I did the distance formula in my head because the two parts were the same, but I probably did it wrong. So 3 root 2 squared. So actually,
should
check
be 18,
my work.
Right?
Yep. Oh no, it is 6.
Okay,
I don't know why I thought it would be 3 root 2 because You're adding. Okay, just kidding. So it is 6, and that would be pi 4.
You're good. Okay. Awesome. Next. Okay. So my initial guess without doing work is that it's C. Because if it has a 3, doesn't that usually mean there's 3?
Or it means that
petals?
It will finish 3 times in 2 pi. So I think that's right, but I want to do work just in case, because I've gotten things.
Well, how do you check this?
I like, plug in points.
Okay. So like, say at pi halves, what should it be? Mm-hmm. Like that?
Yep.
Okay. Yeah, I think it is C.
Our answer is the same.
Oh, nope, they're not. I'm doing C. It's your B.
Okay, good. Yeah, so pi halves, it is going to have to be.
Yeah, it should be 3.
Wait, is that already 2 at... That's a radius of 3 here.
Yeah, that's what I got, because if I did pi halves, I ended up with 3 pi halves, which is negative 1 times negative 2.
Let's take the 2 in front of it. Yes, that's right.
Yeah. Okay.
None of them have 2 at that point now.
Look at the little guy, though. So it's like... I don't know. That's awesome. It's the only one that works, because it's the only one that has a 3.
Yep, because it'll start the negative number, so it's sketching behind it, and then it comes up, down, done.
Yeah. Okay.
And I'm still kind of tired, I guess.
Oh, that's okay.
That's what I get for not sleeping.
You're one of those, huh? Don't sleep.
It was a work had extra stuff this week because we needed to give reports to the parents on how their kids did in swim lessons. So I got to do that all night, every night.
Oh, I am so sorry.
I spend way too much time on it, but it's worth it because the kids improve super duper well because then parents know what to practice.
Yeah.
But it's way too much work.
Okay, so the first one, would you say A?
Let me look at it for a sec. Darn it.
Because the others all have lots of things.
Cos of 1/2, so I'm still gonna plug in random, or not random points, plug in points to be sure, because I don't trust myself.
Yeah.
So I think is it my D?
Your D?
Because at pi halves the first time it'll be 0, it'll be 1. The first time it goes all the way around to 2 pi, it'll be -1, which means we should need to have a value of -1. Just kidding, I'm not thinking this through, I guess. What am I doing? Which one were you thinking it was again?
I don't know. I was thinking it was just B, but A. You're A.
That is 0. No, that one doesn't have a value of negative.
It doesn't have a value of -1.
So
where should it be -1?
At 2 pi. Because it's half of the theta. So 2 pi would be where pi is normally. Okay. So it needs to have a value here when it gets around to the other side the first time. It's around to here the first time. That's not -1 though, so it can't be my D.
Maybe it's your B, my A. Because, well, except
it had to be.
But at pi, I was getting.
Yeah, at pi,
yeah, there's a value
0.
There still. Right.
So, is it the really complicated looking one, maybe? Wait, what? Maybe not. I'm confused now. So it starts at 1.
The homework said to use technology, right? Whenever I asked for help, it said use technology to graph this. So let me see what I get.
Let's see what the period would be. So. I'm thinking it might be the really complicated looking one.
Come on. It's the other one. It's
this.
It has 2.
This one, my D or my B?
Your B.
My B.
Mm-hmm. It does go between 1.
Oh, I think that. Oh, I think I understand. Yeah, I know what. Yeah, I understand what it's doing now.
Okay.
It's like making an infinity in the middle. I thought it was like corkscrewing around. So it is back at 0.
No, I guess that does make sense.
Yeah, that makes okay. I can live with that.
Okay, cool.
Dun, dun,
awesome.
Yeah,
hey, 3 cosine should be easy. The next one.
Yep. We start at 1.
It's your D. Hey, it's my D too.
1, 2. Right. Whatever. 1, 2, 3. Yeah. 4 would be.
This one messes me up.
2.
Wouldn't it have to have petals?
What
Clearly
was that
not. Doesn't it have to have an even number of petals? Like it can't have 5 petals.
I remember the trick for it. So it's my B because there's 4 petals after the first one in the first 1, 2, 3, 4 in the first half of the rotation. 1, 2, because there's 8. 4
yeah,
pi.
okay.
That's more of a I accidentally memorized it one.
Well, thank you. So after the first petal, there's 4.
It traces 1, 2.
Oh, if you divide it in 2, there's 4.
4. Yeah.
Okay, cool.
1.
And then 5, would this be the same as the 3 pi has 3 petals, or 3 theta has 3, so this has 5?
I think so.
Or is that incorrect? Maybe I'll double check.
1, 2, 3, 4. Yeah. So I do it by tracing the period, seeing where we end up at the.
Oh, perfect.
So yeah, that should end up being right.
So wait. Oh yeah, you clicked D. Okay.
Yeah. Sorry,
awesome.
I was tracing A just to see what happened for it.
Okay, cool. Next, I have a feeling this is going to be difficult. Yep.
Cardroids. That's not how you pronounce it, but I'm gonna pretend it is.
No, I don't even pretend to do that. Okay, region shared.
Region shared by the Larrys. So do we want to do the area thing?
Yeah, how do you do it if there's 2?
That wasn't in the reading, so that's interesting.
Right.
Huh. This will take some thinking. Darn it.
Area shared by the 2. Should we graph them and see?
So they gave us an equation for dA. We could find where that overlaps.
How do you find where that overlaps? Because that just gives you
dA as opposed to A, just set the 2 equal to each other for where. No, we want to find where the areas are equal, so that's setting the integrals equal to each other.
Well, you have to find out where their actual position is mapping, correct?
Mm-hmm. Huh.
That's
we change it into, we probably don't change it into the, I forgot the name for it, cardinals, whatever. Cardinal coordinates. Cartesian, that's what it is. I found the word. Probably don't convert it to Cartesian because that doesn't look like it would be pretty.
Not so we at have all.
radiuses and angles. How is that useful? Time to draw pictures.
Oh, hey. Well, okay, I just plotted it. Here, I'll share my screen with you. Maybe. Let's just do. Okay, can you see this?
Yeah.
That's just the first one. So the second one, we're going to be looking at a really small. Because I imagine it's just flipped over the y-axis with the negative cosine.
I don't think so. It's going to be just because the coefficients are different. It's going to look slightly different.
My coefficients are the same.
No. I mean a -1, or sorry, not the coefficient, but you're subtracting a cosine from something as opposed to adding a cosine to something. So it'd be like shifted left and right, kind of, if it was normal, but it's not.
See if...
It's the radius that's changing instead of position that's changing. It's probably going to be moved over slightly and smaller.
Okay, it's not graphing it in polar. Nope. Oh, wait. That didn't work.
Yeah.
I'll just do this one. No, it is. It's just flipped. Because it's the cosine that's negative, not the one.
Okay, just kidding then.
The one stays the same. Lena, you okay? Okay, but still mathematically, that doesn't really give us anything.
No, but
It just gives us where it crosses the y-axis.
But we can kind of see the angle set. So the areas.
You know what we could do?
We can set. Should we do inequalities to make it areas?
We could. My only thing is, if you were to draw like theta, or yeah, an angle from here, you'd still catch some where it's not overlapping.
Well, if like 2 pi, if you go back, or no, okay, sorry, my bad. 2 pi radians, it would be negative, so it's underneath the thing in that one. It is positive on the other.
Wait, so should we just set them equal to each other? No, because that's just when the radius is equal.
Or so if we add them together, and if it equals 0, they'll cancel out to not have things and stuff. And wow, I'm tired.
Yeah, try explaining that one more time. I'm not sure.
I don't know what I'm talking about either. Don't worry.
So what would happen if you set the two r's equal to each other? Would you find where they overlap?
You'll find any place where they have this.
You wouldn't find anything.
You'd be looking for places where they have the same radius. Places they have opposite radius is going to be.
So if we set them equal to each other, they would have the same radius, right?
If you add them together, then any spot that's positive will have a greater positive, or that have the same sign will have a greater sign. But any ones that have a different sign will have cancel out and become 0. Fit the two radiuses together, theoretically.
Yeah.
I'm going to pull up a graphing thing from my end too and do it.
It's just going to be 2 cosine theta. Which leaves us nothing. 2 cosine theta equals 0.
I'm going to test something for myself.
That really doesn't work. Okay.
And my shenanigans not working. That wouldn't be the first time.
That only gives us where they have the exact same number, not where the area is covering.
And we probably want to find areas. And then
I have an idea. One thing we could do is find the area of which one is it that has okay, so find the area from negative pi over 2 to pi over 2 of 9 times 1 minus cosine, and then just multiply that by 2. Because that'll give us the area. Yeah, I'll pull this up. And then maybe that will be helpful. Okay, so find the area from negative pi over 2 to pi over 2, and then just multiply that by 2.
That would be the smart way of doing it. Or you could just find it from 0 to pi over 2 and multiply it by 4. The area
but they don't cover this area.
The area underneath is negative in the negative pi over 2 to 0.
Oh, so you're saying like from here to here?
Just the area in the first quadrant and multiply it by 4.
Okay, let's do that. I like that. Okay, so our bounds are going to be 0 to pi over 2 multiplied by 4. And we'll do, isn't it 1/2 r squared?
Yep. And that's the plus cosine graph instead of the minus cosine graph you showed me?
That was the minus cosine graph, I'm pretty sure.
Good.
Yeah, it's minus cosine. Okay. Okay. So the 9 is also squared, right?
Mm-hmm.
No, that sounds dumb, but...
If you distribute before you do the square, it looks like 9 minus 9 cos, or 9 minus 9x form. So you do the like 9 minus, or 81 minus 81 cos theta minus plus 81 cos squared theta.
Hang on a sec. Okay. You get 81. Wait.
Because I'll pull up my
yeah, you should show me what you're doing.
The phone webcam is, this is not the purpose I thought it would ever serve, but I'm glad I randomly found this app once upon a time.
Awesome.
Because I'm still too cheap to buy a webcam. Browser. So because you can distribute this out to this form, and let's say we, come on, be good quality for once.
Isn't that negative?
Because like the cos theta could be u substituted, for example. It would be like your perfect squares form in your answer. 81 minus 81.
So it wouldn't be, you wouldn't do, so it wouldn't be negative 2 cosine theta. It would be.
Oh no, it would be negative 2 cosine theta. You're right. Or negative.
So actually be.
Theta. Or wait.
162 cosine theta.
So it would be cosine 9 cosine. It would be 2 times 81. So.
Yeah. Okay.
Yes. I always do little mistakes like that. It's every single time.
Oh, that's okay. I do too. That's why we do this together. Okay.
I once did my calculus homework on the board in front of class in AP Calculus, and realized that because I said like, well, I don't know that she'd always have us do our homework on the board in front of the class if we wanted to.
Oh, that's difficult.
I know it was the best because then you learned it. And a few people realize that. Saw it oscilloscope and say, I don't have the answer, but I think I got close. I wrote up my work, and I realized that my one mistake was I accidentally said 1 + 1 was equal to 3. And was off by 8 million.
Awesome. Oh, wow. Okay.
It was literally calculus.
I'm having a really hard time with integrals this week for some reason.
So when it's
how are we going to integrate that?
When it's addition, you can break up each different part into its own integral.
Okay, so that shouldn't be too hard because we can just pull 80. No, we can't. Is it 81x, right? Negative sign. So how would you integrate 81? Because aren't we looking for theta?
Or so you can move the 81 out front to make it a 1 inside, and the integral of 1 is theta, and then you do over the range 2 pi to 0. So it ends up being 162 times 2 pi minus 0 for that integral. I'll double check my cheat sheet from high school.
Okay.
But the integral of a constant number is, at least should be a nice thing to do. If it's on.
Okay, so the 162. Isn't it?
What? Which 162?
I only had one.
Wait. Do you mean before moving an 81 out, or the 162 cos theta?
Okay, so you move the 81 out and then you multiply it by 2. Is that where you're getting the 162?
Yeah.
Okay, thank you.
Sorry.
I just hadn't multiplied those out yet, so.
My bad.
162, and then it is just times by theta?
Or the theta stays inside the integral. And then this.
Well, the 1 stays inside the range.
Yeah, the 1 stays inside the integral, and then it's times the top range minus the bottom range. Pi halves minus 0.
Yeah, okay. So pi halves.
Yes.
Is what you pull out.
But I say that because I've been burned so many times when the bottom isn't 0. And then yeah.
Oh, yeah.
If I don't say that every single time, I'll forget.
Okay, and then for the next one, it would just be negative sign, wouldn't it? Well, yeah. Negative 162 sine of theta, which is 1.
Wait.
Isn't it?
162 sine of theta.
Would be 162. Well, negative, because it's still negative, right?
Yeah. Or again, you'd shoot the 162 out front, multiply it by 2, and then you're left the cos on the inside.
Wait, why are you?
Because you always want to stick out coefficients in front of there before you any derivative.
Right, but why are you multiplying this one by 2?
Everything is multiplied by 2 because that was in the original integral. when you break it up, every integral is still multiplied by 2. It distributes.
Okay.
Webcam up.
So it's still negative though, right?
Yeah. Sorry. Browser works.
Minus 324.
So the 2 that was up here, once you're ready. 2 that was up here.
You multiply each.
Parts, each one's multiplied by it. So it's negative.
So negative 324.
Yeah.
And then, so the way you do it is you just do it like one step at a time. You pull it out, the bounds and everything.
Yep.
This multiplied by already pulled out, right?
Mm-hmm.
So the sign of pi over 2 is 1 minus 0.
Or minus sign of 0. Or did you say, oh yeah, it's 0. Just kidding.
So, yeah. Okay, so the last one. Oh, my pencil's falling apart. How do you integrate this? Cosine squared.
That would be, give me a sec. I'm going to do up in the top.
The trig identity thing?
Or you could use substitute.
I feel like he did one of these in a video that was, it turned it into like cosine of 2 theta. 1 minus cosine 2 theta or something. Cosine squared theta is equal to well, that doesn't do any good. Oh yeah, no, that doesn't do good. Okay, so the cosine of 2 theta is equal to 2 cosine squared theta. So we just need to multiply a 2 somewhere.
Say that again, please. The cosine of 2 theta is equal to.
I'll just show you. Okay, no, I'll just tell you. So theta is equal to 2 cosine squared theta.
Oh, we can just push a 2 from the coefficients that were out in front of that. Because we have 162 in front of the integral. You can move a 2 back in.
Piece of cake. Okay, so then
it's not shenanigans. It's totally allowed mathematically. It's just not what I would think of doing.
Well, yeah, I get that because you could just pull a 1/2 out to multiply it 2 by 2. Makes sense.
Yeah.
So in that case, it would be sine of 2 theta over
2 because over 2.
Okay, awesome. So out front, do you have
an 81? Because he stole the 2
80.
from. He stole the 2 for the shenanigans.
What about your 162 pi over 2? What'd you do with that?
That became 81 pi.
What happened to the pi?
Out the 2.
I'm really confused.
Or the 162 pi over 2 from where?
That was the very first one.
So
from the 81.
162 is 81 times 2. 81 times 2 times pi divided by 2 is 81 pi. You can cancel out the 2's.
But you still have the pi.
Yeah. It's the
Okay.
group quiz says type an exact answer using pi as needed.
Right. Sorry, I'm not looking at that. Okay, so did you do the sine 2 theta over 2 still, or not yet?
I'm just writing that in now.
Should equal 2 on top. So it should just be multiplied by 1, so it's the same. I think. Oh, but it's plus. It's plus. Plus 1. Right? Wait. Okay. So these are just added together. They're not multiplied. So how are you canceling the 2's?
In the 81? Or where am I canceling the 2's and where?
So you said you canceled all the 2's, but...
No, only in the 162 times pi halves. Because there's a divided by 2 on the bottom of the pi halves.
Okay. So that's 81 pi. And then
324.
I'm so sorry.
It's good.
And then minus 324. And then plus 1?
Plus 1.
Because the sine of 2 pi over 2 is going to be 1. Or 2 theta.
Sine of 2 theta.
Over 2. Isn't it?
It's going to be
0.
No,
I'm thinking wrong.
And then sine of 0 is 0. Sine of pi is 0. So
Yep, you're right.
Yeah.
So 81 minus 324?
Yep.
81 pi. But now we have to multiply that by 4. Right.
Oh, I already did that earlier.
Oh yeah, we did.
From the very, very beginning.
You're right.
That's why it was a 2 instead of a 1/2.
Okay, you're right. 81 pi minus 324. Awesome. Okay.
That looks like a calculus answer to me.
That looks like a terrible answer. Goodness.
Oh.
Let me just double check that I've marked everything that I wanted to, because I feel like I would mess that up. Hey, sweetie, you okay? Awesome. Okay. Let's see how we did.
Dang it. What was question 4?
Wait, how did I miss question 1? I missed something on question 1. Did you?
That's not nice. Don't do that to me.
I don't think that's correct. I wonder if he did that wrong too. Because we both got those answers pretty easily, pretty quickly.
Yeah. And we got the same radii. We just have different angles. Sine inverse.
Yeah, but ours is right because he has pi over 6, but it has a negative, so it can't be pi over 6.
You mean 5 pi over 6?
No, we were right, but so I look at his, oh no.
Because ours is over 6 as well. It's just 1 pi over 6 instead of 5 pi over 6.
Yep, ours was wrong because there's a negative x.
Oh my goodness.
We didn't even look at that. Well, that stinks. Oh boy.
And then question 4 was wrong somehow. At least we got the single number right. But apparently it wasn't 162, but it was secretly 243. Because we got
get to be 243.
I don't know. Like, what?
Okay.
9 times 9 is 81. 81 times 2 is 162. So what?
Like, yeah, beats me.
Like what?
Well, we should ask him. Dang. But we got the second one right, so.
Yeah, we got the one that wasn't the integer. It's supposed to be easy, but secretly isn't.
We'll just email him. So where did we go wrong there?
Either we went very, very wrong from the very beginning, or a little wrong somewhere.
I imagine we went a little bit wrong. Dang.
I mean, 324 is 81 times 4. So it could have come from different places. I mean, there's 9s and okay. I don't know.
Have your quiz 3?
My quiz 3?
Yeah, do you have any questions? I am just wondering where I went wrong on.
Oh, I haven't even looked at it yet, so.
I just barely looked at it this morning. But question 3, I missed 1 point on B and 2 points on C, but I don't know why. And I didn't get 5 right. Or I got -1. How do you -1 on 9? Anyway, maybe I just don't know how to do it.
I don't have the test in front of me, so these numbers mean very little to me right now.
I'm sure.
The week 3 quiz submission, right?
Yeah.
Okay, which one did I get wrong? I got 6. 6 is the only one I got wrong.
Okay, awesome. So you can help me with what are your numbers for 3B?
3B.
They're really weird.
Yeah, they're strange. They're ugly.
Okay, so I did different. Wait, I can't really see yours. Do you have 55 over 15? Maybe?
Yeah, or 52 over 15.
Maybe that's where I went wrong. I just did. Because your other numbers, you have 83 over 30 and 5 over 6, right?
Yeah.
Okay, so is yours -52?
Yes.
-52 over 15. So I must have done something arithmetic right there.
Yep.
Yeah. Okay, I was wondering because I knew it should be 0 and I ended up with -2 over 5 at the end. So, okay. And then what did you get for 5?
5. 3.
That's what I got too.
What?
Whatever, maybe I just wrote it wrong. Okay, and then so for 6, I got for the x component 2t plus 1, 3t plus 5, 5t plus 7. Oh, you're
my t is wrong here.
Yes.
Okay. What's it supposed to be?
0 to 1.
0 to 1.
Yep.
Oh my goodness. Okay. Yeah, that was just me not understanding what I was doing.
Okay, awesome. Well, thanks for your
help.
I feel
like a lot of these might have been really, really lucky guesses. So probably this next quiz is not going to be too well because I burnt all my luck here.
Well, you did awesome.
Yep.
Cool. Well, thanks. I think we're good.
Awesome.
Thanks for meeting this morning.
Yeah, I'll send you the link and see you next week.
Sounds great. We'll see you.